as fast as I can. So the host name, ESXi IP address. This is the external management. Here we have ESXi management user. Password should be the same for everything. Should be this one normally. Okay. And here we have number 4. Okay, vSAN. Motion. Okay, so it's going to take some time. Let's talk about how do we create storage policies. So, storage policies are important to your vSAN environment. That's what will help you to determine how the data will be placed and how the data for your different VMs will be protected. So ideally in a production environment, you're going to have a library of policies that work best with all the workloads you are deploying. There is no universal policy that works for everything. Each VM would run software with a specific requirement. So the best you can do is to, from a storage point of view, just build a policy that based on recommendations from the software vendor. The software works best with Red 1. You should build a Red 1 policy. If it works best with Red 5, for example, you should go with Red 5. So how do we build policies? You go to the menu, okay? From here, menu, then policies and profiles, and then you have VM storage policies. From there, you can click on create a new policy. There are different ways of creating policies. You can clone an existing policy, make some changes to it, okay? Or you can create one from scratch. So here we're looking at the creation of a policy from scratch. So the policy is going to be tied to this vCenter. You need to give it a name, okay, and description. Ideally, as a best practice, if you are a team of admins, you should have a naming convention that is well understood by everyone, from which you can easily understand what the policy is about and what's its structure, what kind of thread it's using, settings, etc. You can also add a description. Then you click on next. After that, you need to enable rules for vSAN storage. Okay, click on next. And after that, you get to choose from the list available here. So this is about data placement. The first setting is the site disaster tolerance. This will specify which kind of cluster this policy is dedicated to, and you have different options to choose from. Okay, so first one, as you can see, standard cluster. If the policy is going to be applied to VMs running in a standard cluster, you need to select the first one. Second option, host mirroring 2-node cluster. Self-explanatory. If you are running a 2-node cluster, you should select the second one. If you have a stretched cluster, the last 4 options are for you. Okay, I'm not going to talk too much about them for the moment because there will be discussion later about stretched clusters. Okay. Next, you will need to select the FTM, the failure tolerance method, and the FTT. So you have no data redundancy, which is red 0, and data can be placed anywhere. I can have a VM running on host 3 from a compute point of view, and its data placed on host 1. Or I can choose no data redundancy with host affinity. And in this case, the data will be placed into the same host where the VM is running. Okay. Or I can select a failure of 1, and you have the option to go for red 1 or red 5, failure of 2, red 1 or red 6, or an FTT of 3 failure, which is supported only on in red 1. So these are the different options available. Here you can see the number of hosts required for each one of these policies. We already discussed this yesterday, but as a reminder, for red 1 with an FTT of 1, you need a minimum of 3 hosts. So component, witness. FTT of 2, red 1, 5 hosts minimum. Component, original data, 2 additional components, 2 additional copies, and 2 witnesses for each copy. Okay, created automatically. So that's 5. FTT of 3, original data, 3 additional copies, that's 4. 3 additional witnesses, that's 7. These are actually the minimum numbers required for each one of these policies. In other terms, when we talk about minimum, it means that you can't rebuild if there is a failure. You have only 3 hosts, red 1 with an FTT of 1. If you lose 1 host, you can't rebuild the data. Okay? There is a simple way of calculating this for red 1 if you want to just keep that in mind. 2n plus 1. Okay? So 2n plus 1. N being the FTT. For example, red 1 with an FTT of 2. So that's 2n plus 1. 2 by 2, that's 4 plus 1, 5. Okay? If you want to have an environment with self-healing capabilities, the possibility to rebuild in case of a failure, just add 2 instead of 1. So 2n plus 2. That's 6. If you have 6, you have a failure, experience a failure, and you can rebuild. For red 5, you need 4 hosts minimum. For red 6, you need 6 hosts minimum. Okay, let's see. Okay, put the host in maintenance. I'm not going to put that host into maintenance. Okay. Just want to make sure that everything is running as it should be, and then I will let the software add the host and continue the explanation. I'm going to get back to this later. As you can see, it's now being added. Okay. Next, we have the storage rules. Okay. The storage rules is actually a tab, the next tab. The first one is the availability. The next one is storage rules. Storage rules is actually a tab that will let you add like filters about what kind of storage you are looking for. This is ideal if you have multiple data stores. You are probably wondering, hey, wait, you said yesterday that we only have one vSAN data store. How can I have multiple data stores? There is a feature that's going to be covered next called HCI mesh that can lead to having multiple vSAN data stores within the same cluster. And if you have multiple vSAN data stores, one of them can be all flash, another one can be hybrid, one can have encryption. So the policy you are building will actually be used maybe on just one of these data stores. So you're going to need to apply some filters here and show only the data stores that meet the requirement of this policy. That's exactly what this tab is all about. It will help you to apply some sort of filter. For example, you ask for, let's say, deduplication and compression, you need to select this and select all flash. Next tab, advanced policy rules. First of all, for the advanced policy rules, if you don't really know what you are doing or what you are making as changes, the best you can do is to keep the default settings. The settings here will act on generally performance. This can either improve the performance or hit the performance if it's not well used. It doesn't really guarantee an improvement in the performance in all situations. Okay, this will mainly depend on how the environment is and many other factors. Okay, so I'm going to talk about each one of these options in details. Let me just load again the software of the tablet so I can start drawing. Okay. All right. So first option, number of disk stripes per object. Okay, this one. Minimum value, 1, default 1, maximum 12. Okay. So since yesterday, we said that when you place an object, let's imagine that we're going to use red one with an FTT of 1. Okay, we said that vSAN will by default place component, and witness, right? Each component is a replica for the object. So if the object is 100 gigabyte, each component will be 100 gigabyte. By default, each component is going to be placed into a physical disk. The final destination for the components are the capacity drives. Okay. Here's a situation. Let's imagine. Okay. Let's imagine that your object isn't 100, but it's actually 250. That's the size of the disk you gave your VM. Unfortunately, you only have, or let's make it simple, 200, okay, 200 gig. And unfortunately, the capacity drives in your environment are 100 gigabyte each. It's not possible to place this object as a single component in each one of these drives. So in this case, vSAN will automatically stripe that component into 2 subcomponents of 100 each. Okay? This is less likely to happen in modern environments because capacity drives are generally bigger than the size of the objects themselves. So I just used this to explain what striping is. It's basically splitting the component into multiple stripes. This can act on performance in some situations. Let me give you an example. We have a hybrid environment made of certain number of hosts. Okay? We know that in a hybrid environment, read performance can be hit when you are reading from the capacity drives because the data is not available on the cache. Okay. You have an application that requires 200 IOPS. Okay, and unfortunately, your capacity drives, being hard drives, are only capable of 100 IOPS each. Okay, so this means that if we place a component into one disk, that will severely hit the performance if you happen to read from the capacity drive. So in this case, striping can help by selecting a number of 2 here. Okay, this will automatically split each component into 2 stripes. For example, C1, C2 here. Having an object of 100 gig means that 50 gig will go to the first disk, 50 to the second one, and that's going to help in this case. If you are reading from this environment, 50% will come from the first disk, 50% from the second, 100 IOPS. So you're going to end up having 200 IOPS. That's the requirement. So you're good. That's from a read point of view. From writing, when writing the data, if you have a single cache, that's not going to help at all, because all the writes will lend or will be written to the same cache anyway. You don't have redundant caches, disks, so everything is going to be written to the same cache. Right? So there are situations where vSAN will proceed to striping automatically. Some other situations, you're going to see a single stripe. If you don't touch this manually and you see multiple stripes, there are situations where vSAN will need to do that, other than the first one I explained. But we're not going to go into more details. So that's the first one. Second one is called IOPS limit for objects. Okay, this is the second one. Default value is 0. Okay, you can set number there. vSAN is actually shared by all the VMs you run in your environment. All the VMs will write and read from vSAN. They will have equal chances to read and write from the same storage. But we all know that not all the VMs are at the same level of importance in a production environment. And unfortunately, sometimes the VM that consumes most of the resources is not the most important one for me. Recently, I was talking to a customer, and he said that we have a Syslog server, and that VM is really consuming too much resources in their vSAN because it keeps writing again and again. It's a Syslog server. Okay, its main role is to collect the log and centralize all that in a single location, give you all the fancy dashboards that, as an admin, you would like to see. So one way of limiting the access to the resources is to apply this setting. So instead of giving a limited IOPS access, you will limit that to a certain number. Remember that this is a policy. So it's applied to a single VM. You can also apply it to an object. If that Syslog server is made of 2 objects, one is running the application, the second disk, for example, is running the database, and you want to limit the performance specifically for that object, you can apply it to a single object. This will apply limit to that object alone in your entire environment. This is like quality of service setting for vSAN. You can monitor the limits and how it's being involved. So here the fourth host was added successfully. That's perfect. This is a setting you can monitor from here. So you go to the performance, look at the virtual disk. Here is the IOPS limit. So if you limit it to a certain number, you definitely see that once the VM or the object is trying to consume more than what is it supposed to consume, vSAN will throttle it down. Next, we have object space reservation. This is about thin and thick provision. Are you guys all familiar with these concepts? It's purely storage. Thin and thick. Are you guys familiar with that? What about the others? All good? Thin and thick? Thick reserves room for growth. Okay, and what is thin then? So the reason I'm asking you these questions is just to avoid spending time on something that everyone is familiar with. But if there's something which is completely new for you, I can briefly talk about it. Okay. So let me briefly talk about this. So what's thin and what's thick? Let's imagine you have 1 terabyte of storage. Okay. You have 2 VMs. First one, VM1 and VM2. VM1 needs 100 gigabyte. VM2 needs also 100 gigabyte. VM1 is for the HR department. They are asking for 100 gigabyte, and you know that the application requires exactly 100 gigabyte. Okay, the application requires performance, and you know that they will not need more than that. Okay, so you're gonna give them 100 gigabyte as a thick provisioning. This means that we're gonna take 100 gigabytes from the storage and make it available for that VM. So if you look at how much storage is available, you will see 900 gigabytes. Okay, assuming that 1 terabyte is 1,000 gigabytes. Okay. Now for VM2, VM2 will be dedicated to the finance department. And you know that these folks are always asking for more than what they need. You don't want to get in trouble with them. Yeah? They will accuse you for, not providing enough storage and stuff. You know that they will only consume 20 gigabyte. So you will answer by saying, okay, I will give you the 100 gigabyte in as thin. What does it mean? It means that from a VM point of view, the VM will see 100 gigabyte, but in reality, it's not really 100 taken from the storage. We will consume the storage as needed. For example, if they install the operating system plus an application, and that will result into using 20 gigabyte of storage, we will only consume 20 gigabyte from here. Okay? So that's actually how it works. Thin will consume storage as needed. Thick will take that storage immediately. I'm not going to go into details because this is definitely not a storage class, but the way it works will require additional maybe reading later, how the blocks are provisioned and stuff like that. So vSAN being a storage system will also ask you if you want a thin provision or thick provision. You have different options. You have thin, default one, or thick, or something in between, 25%, 50%, 75%. What you need to keep in mind here is that thick will always give you the best possible performance. Because when you thick provision, storage is immediately available. We don't need to prepare it when we need it. It's already there. It's already available. Thin will give you good performance, but this will all depend on what kind of architecture you are using. In modern systems, especially if you are using all flash in VME, you don't really feel the need for having thick available for your different VMs. Thin will work just fine. It will give you very good performance. Okay, so thick is to be used when you really need extreme performance, because thick can be considered as a waste of storage if you are not really consuming all that storage. Can you imagine the first VM being given 100 gigabyte and it's just consuming 10 gig? It's a waste of 90 gigabyte, which you may probably need later for something else, but due to the fact that you completely allocated that to the first VM, you can't claim it back. Another thing you need to keep in mind, for deduplication, you either use thin or thick, not the options in between. So that's object space reservation. Next we have flash read cache reservation. Must be kept to default 0. This is gonna reserve some of the flash. It's for hybrid. Normally VMs will share that available 70% for read from the cache tier, but you can reserve certain capacity for one VM and give it this policy. It's really something you should not really modify unless it's instructed by support. It can help in some situations, but if you do this without really knowing what you do, you may end up with some capacity reserved for a VM that doesn't really use it. And again, it's going to be considered as a waste of storage. It's even worse because we're talking about cache here. Next one is disable object checksum. Pay attention, we're talking about disabling the feature, not enabling it. This means that the feature is enabled by default. The checksum in vSAN is an algorithm that is run every 15 days. In the background, doesn't ask you to enable it or disable it. You have no control over this feature. What the feature does is it's going to look at media errors. It's going to look at the physical disks and see if there are any issues. vSAN is capable of looking directly at the disks and you know, if there is any issue with one of the disks, it can proactively move the data accordingly and, you know, help to avoid situation where the data is lost or requires rebuild due to predictive failures. So it can detect some sort of failures, which are called predictive failures. For example, failures at the block level, logical failures, and it can proactively rebuild the data without asking you about rebuilding or not. So this feature being enabled by default across the entire cluster, you can disable it for specific VMs. Some VMs will run applications with checksum implemented natively into them. Some databases, for example, can do that. So you don't need to do it at the hardware level or at vSAN level. If it's done at the application, that's good. I can disable it. The last option you can see there is force provisioning. Force provision is actually a feature used only in, it should not really be used. I don't think that there is any other use case other than the one I will describe. For example, you have, in our lab environment, for instance, if you try to create a policy for RAID 5, let's say you need to create a policy for RAID 5. RAID 5 requires, as a reminder, 4 nodes. You don't have them for the moment in the lab environment. You only have 3. The wizard will tell you, I don't see any vSAN compatible data store because you don't have the minimum number of nodes. Okay, I can show you that in the lab environment. For instance, if I go to the menu, policies and profiles, and I try to create a policy that requires more than the number of nodes we have. Look, I'm going to go ahead and select RAID 6, for instance. I need to specify all flash. I'm going to click next. and I don't have any compatible data store because my environment is limited to 4 nodes only, which is not enough. For RAID 6, I need 6. And as you can see here, my data store is visible as incompatible. Okay. If I enable force provision, I will be able to see my data store. So how does it work? Well, this feature tries to force things by deploying the objects in RAID 0. So in our lab environment, if you select force provision, create the policy using RAID 5, what's going to happen is your VM will be deployed in RAID 0. And vSAN will keep monitoring the environment. At the moment, it can find resources to satisfy the policy, which means when you add the 4th node, it will automatically migrate the VM from RAID 0 to RAID 5 to make it compliant with the policy. Okay, so this is ideal if you want to quickly deploy some workloads. For instance, you just received, you are deploying a 4 nodes cluster. Okay, for some reason you only received 3 nodes, and the project must be completed in the next 2 or 3 days. Start deploying the cluster with 3 nodes. You are asked to deploy a couple of VMs, so you can use this feature. And then, if the 4th node is delivered maybe or shipped or available on site after 3 days, once it's added, vSAN will automatically recreate the components using RAID 5. So this concludes a look at the advanced policy rules. Again, if you don't really know what you are doing, best you can do is to keep the default settings. After that, the wizard will show you, the compatible data stores, and just go ahead and click on finish. Your policy will be available. So let's do that together. I'm just gonna go back to my initially created VM. So this VM has, let me show you, 2 objects, the home and VMDKs using RAID 1, default policy RAID 1 with an FTT of 1. I'm gonna go ahead and create RAID 5 policy. So it's called RAID 5. And since I have 4 nodes now, I can select RAID 5, all flash, next. Okay. If I go back to my VM, right click, VM policy, edit, and I can select RAID 5. This can be done live. As you can see, it's going to tell you that we're going to consume less storage. Okay, let's refresh. Here I can see the 2 components. These are the components, the original ones in RAID 1. The system is creating components using RAID 5. Now that it has finished, I can only see components of RAID 5. Okay. I can change components for specific objects. VM policies, edit. I can configure per disk, as you can see. So I'm going to change this to RAID 1. Okay, let's refresh. So as you can see, VM home is RAID 5 and disk object is RAID 1. Okay. For policies, I can make some changes to them. So I can select my policy. I can run a check. I can edit it. I can clone it. I can reapply it. I can delete it. I can't delete a policy which is being used. That's not possible. If I click on edit, I can make some changes to it. Okay. Go to the advanced settings, select stripe of 2, click on next. Here, as you can see, since I made some changes to this policy and being in the policy being used, vSAN can detect that, and it's telling me, hey, this policy is currently being used. Do you want to apply the changes to the VM now or manually later if you don't want to impact the performance? I'm going to go ahead and select manually later. Okay. Now I can reapply it from here. But before doing that, let me just go back to the lab environment. And if I show you the compliance of this VM, have a look here. So for the disk, the object that we didn't touch using red one policy, it's compliant. For the first one, it's showing out of date. This means that vSAN has detected that this policy has seen some changes, and those changes has not been applied yet to this object. So let's reapply to make this component compliant, and here we go. Now it's compliant because it's now using the most recent version of that policy. Okay. So these are the different actions we can do. We can change the default policy of our data store by selecting the data store. Then you can go to configure, general, default policy, and you can set it to something else. If you have an all-flash environment, for example, and you want to make your RAID 5 as the default policy, you can do that from here. How do we apply a policy? Well, it's when you create a VM from scratch, you reach the select storage, then you select your vSAN data store and change the policy from here. If the VM is deployed from an OVF template, you can do that from here, select storage. If the VM is deployed from a template, so select storage, again, you select the data store, then change the policy from here. If you clone a VM, similarly, when you reach the select storage step, you can configure the policy from here. Okay, couple of considerations. The policy can be changed live. Okay, you can check the compliance by looking at selecting the VM, configure policies. You can see if the objects are compliant. If you want to change the policy, you can change it at the level of the entire VM, as I showed you, or change per object. This is very, very interesting because it's if you have a VM that runs multiple, or a VM with 2 disks, for example, you need RAID 1 for example, the first disk and RAID 5 for the second one. You can assign different policies to different disks. That's really a good option. Now, before changing the policy, you need to make sure that you have enough capacity first. I already talked about this morning, because at a certain moment you will have components of RAID 1, components of based on the original policy, and components based on the newly applied policy that coexist at the same time. That's going to result into an additional storage usage or higher storage usage. It's highly recommended to apply the changes to a single object and measure the impact. If you have no clue what kind of policy needs to be used for a specific workload, have the policy applied to a single object, look at the performance statistics, and see if the impact is really huge, if it's working well or not. And that's going to help you to decide if that's the best policy or not. Okay, so these are some of the recommendations you want to apply policies, and of course, ensure that you have enough full domain, enough hosts for the policies you would like to create. You can't create policies without having the exact number of hosts.